Hello students, I welcome all the standard 10 students on this online class. I hope you all are studying properly. Yes, you go through your book properly, read it, and whatever we are discussing here, also listen carefully. Last class we have discussed about some examples related to moment of force. But today we will be going to discuss about equilibrium of bodies. Okay, you study this one properly from your book also. Okay, so let's start this one. Equilibrium of bodies. It is a common observation that a force acting on a body produces a change in its state of rest or of uniform motion. You all know that one. When an object changes its positions, yes, there are two positions, either an object is moving or it will be in the state of rest. Yes, so there will be a change in the positions because of an agent. What is that agent? That is the force. If a force is applied to a rest object, then that rest object will move, change its positions. And when a force is applied to a moving object, then it becomes, that means it will be going to stop also. That means force is the main cause of changing the position of an object. But a number of forces acting on a body may not bring any change in its states. Maybe there will be a possibility that number of forces are acting, but still because of that force it is not changing its positions. Yes, it may be happen. That body is then said to be in equilibrium condition. If a number of forces are acting, but still that body does not changing its positions. Yes, then it is called equilibrium conditions. Okay, equilibrium also it is defined here when a number of forces acting on a body produce no change in its state of rest or of uniform motion. The body is said to be in equilibrium conditions. If a number of forces are acting, but still that body is not changing its states, yes, then it is called equilibrium. I hope you have understood. When a body remains in the state of rest under the influence of applied forces, it is said to be in static equilibrium. If we consider that object is in the state of rest, and if a number of forces are acting on it, but still if it is not changing its positions or state, then it is called static equilibrium. Static means constant. And if it remains in the state of uniform motion, if an object is moving with the uniform motion, but still number of forces are acting, but even if number of forces are acting, then also it is following the same uniform motion, then it is called dynamic equilibrium. Okay. So for the constant object, static word is mentioned, and for the moving object, dynamic word is mentioned. Okay. Conditions for equilibrium. Two conditions are there. Let us see that one. The algebraic sum of all the forces acting on a body should be 0 when it is possible. When it is possible. That means when a number of forces are acting, but still there will be not changing in the state of an object. Why and how? If the algebraic sum of all total number of forces acting on that particular body should be 0, then only it is possible. This is the first condition. Second condition, the algebraic sum of all the moments of forces acting on a body about the point of rotation should be also 0, then only it is possible. Yes, if all the forces acting on that object cancel one another, or the overall sum is 0, then only it is possible, otherwise it is not possible. So let us see some example. We will go through it so that you can understand more properly. Let us see. So the following are the example illustrating static and dynamic equilibrium. First example, suppose a book is lying on the top of a table. You know that one. Obviously that book is having some weight. Because of that weight, and weight is always acting, the force exerted towards the earth is called weight only. Yes, So that book will apply or exert a force on the tabletop. Yes, exactly same amount of equal but opposite reaction force will be produced by the tabletop on the book. Yes, which is vertically upward and the weight of the book is vertically downward. Both are same, but because of the opposite direction they will cancel each other. Because of that reason only that book is not moving here and there, only it is placing or placed at a particular point only. Thus the book is said to be in the static equilibrium. Next one, when the beam of a beam balance is exactly in horizontal position, the clockwise moment of the force exerted by the object on the right pan equals the anti-clockwise moment of force exerted by weight slot on the left pan. Then only it is rest in the state of horizontal position. Otherwise, it is not possible. If one pan is having more weight, then obviously it will be tilting. Yes, clockwise or anti-clockwise movement will be taking place. But if the clockwise movement is also same and anti-clockwise movement is also same, then only it will be comes in the state of equilibrium condition. Yes, in this position the beam has no rotational motion and thus is said to be in static positions. Okay. In an atom, the force of attraction between an electron and a proton provides necessary centripetal force. You all know that one, all the electrons are revolving around the nucleus. That is, nucleus is the central part. Yes, where neutron and proton are present. And you know that one, proton is also positively charged and neutron is neutral and electron is negatively charged. So there will be a force of attraction between the proton and electron. Yes. So in an atom, the force of attraction between an electron and a proton provides necessary centripetal force to the electron, which moves with uniform angular speed around the nucleus. Up to that means along a particular orbit, on a particular orbit, all the electrons are revolving. Yes. Thus the electron is in dynamic equilibrium with a constant speed, uniform angular speed they will be moving. Sometimes it may not be very fast, it may not be very slow. With a constant uniform speed around the nucleus they are moving. That's why, because here we have considered that one is in the state of moving object, motion. That's why it is dynamic equilibrium only. Okay, I hope you have understood this one. Next one, when a raindrop falls, it reaches the earth with a constant velocity. Two forces, that is buoyant force and frictional force, yes, act on the falling drop. The weight of the raindrop is balanced by these two forces, that is buoyant force, that is the upward force, and the frictional force with the, that means air is present, friction will be happen, and a buoyant force is also acting towards upward direction. The weight of the raindrop is balanced by these two forces. The net force on the drop is 0 and it remains in the state of uniform translational motion only. Thus the falling drop is said to be in dynamic equilibrium. I hope you have understood this much. Okay. Principle of moment, again it is given. If a body is in equilibrium under the action of a number of coplanar forces means forces acting in the same plane, and the algebraic sum of the moments of the forces about any point is 0. In other words, the sum of the clockwise moment, I said that one, yes, sum of the clockwise moment is equal to sum of the anti-clockwise moment. When the body is in equilibrium condition, then only it is possible. Yes, this is called the principle of moment. Thus in equilibrium, sum of clockwise moment is equal to sum of anti-clockwise moment. Okay, I hope you all have understood this much. That verification of the principle of moment practically we will see in your school. Okay, up to that much I hope you have understood. Go through your book, try to solve some examples also. Okay, this much only. Thank you.